Hello, Algebra 2 students. This is the lesson for 6.04. I'm testing Tuesday and Thursday, in-person testing, so I'll be out of the office, and this would have been the two lessons I would have taught this week. So I'm not going to go over this first page, just letting you know that this is 6.04. And I am uploading this to YouTube, so you should be able to stop and start it as you go through it, or only listen to parts of it that you need. These are the announcements for the week. Monday is a fall holiday, no school. Tuesday, 6:06, I'm out of the office due to testing. Wednesday, 6:07. Thursday, 6:08, I'm out of the office due to testing. And then Friday is a catch-up day. We are looking at inverse relationships between exponential functions and log functions. So we're going to learn how to go back and forth between these two functions in algebra. This is something new that you've probably not covered before. So if you've already done your 6.04 in your OHS and you're thinking, I don't think I've ever done this before, then that definitely is the case for most of you. You don't do log functions until you get to Algebra 2. So logs are powers and powers are exponents. So before I start to teach logs, I always like to review exponent rules. So what I'm going to be doing in these 9 little problems is I'm just going to be going over something that you should know. Okay, you should know from Algebra 1, or you should know from the beginning of Algebra 2 that we've already covered, but just in case you have forgotten, it's really important that you know these rules. So rule number 1 says, if we're multiplying like bases, then we add the exponents. Rule number 2 says, if we have something raised to a power and it's raised to another power, then we multiply those powers. Rule number 3 says, if I have more than one thing that's being multiplied inside our parentheses, it's raised to a power, then both of those things are raised to that power. Number 4 says, if you're dividing like bases, then you subtract the powers or subtract the exponents. Number 5 says if you have a fraction that's in parentheses raised to a power, then the top of that fraction is raised to the same power that the bottom of the fraction is raised to. And rule number 6, this is one that I see students really struggle with, and it's about having an exponent that is negative. So number 6 says if you have a to the negative m exponent, that is the same as 1 over a to the positive m, where a is not equal to 0. Because if a were equal to 0, that would put a big fat 0 in the denominator. We know we can't divide by 0. So let me extend number 6. Let me do a couple examples. So if I had 2 to the negative 3, if I had the base of 2 and the exponent of negative 3, then the negative on the exponent means take the inverse. That means you're going to do 1 over. So that means this is really over 1 to begin with. You're going to take the inverse or the reciprocal, however you want to say that. You're going to take the inverse of 2. So you're going to put 2 on the bottom. And as soon as you put 2 on the bottom, that negative 3 becomes positive 3. So the negative is take the inverse. That negative means take the inverse. If I can spell inverse today. And then you would just simplify it from there. 2 to the third power is 8. So put a little star beside number 6. That one usually trips a lot of people up. Number 7 says if you have anything raised to 1 over a variable, then that means that's the nth root of a. So for instance, let me do an example for this. If you have 121 to the 1/2 power, then that's the square root of 121. If you have 64 to the 1/3 power, then that's the cube root of 64. That one also gives people some trouble. Number 8, this is all the way back to Algebra 1. Anything raised to the 0 power is always equal to 1. If you don't know that, take your handy dandy calculator. I think I'm going to sneeze. Hold up. Take your handy dandy calculator. Sorry, had to wait on that one. That's awful. Take your handy dandy calculator and take something like 3 and raise it to the 0 power, and your calculator will tell you 1. Okay. And the last one, this is something that we studied this year in Algebra 2. If you have a base and it's raised to an exponent that is a fraction, it's power over root. So the root, just like a tree, y'all remember me giving you this analogy? We had the tree, the root is on the bottom. So the n is the root, and then the power is in the top. So n is the root, a to the power of m. I personally prefer to do the root first and then raise it to the m power. So the n is the index, which is the root, the m is the power. All right, let's do a few of these. So if I have 25 to the 1/2 power, you're just supposed to know that that's the square root of 25, not 125. And the square root of 25 is 5. If you have 8 to the 1/3, you're supposed to know that means the cube root of 8, and that's going to be 2. If you have 121 to the square root power, you're supposed to know that's the square root of 121, which is 11. 8 to the 2/3, I always do the index first. So I'm going to do the cube root of 8 first, and then I'll raise that to the second power. The cube root of 8 is 2, and 2 raised to the second power is 4. 64 to the 2/3 is the cube root of 64. And again, I'll do that first. I don't want to do 64 squared because that's going to give me a really big number. So I like to go ahead and do the index first and then use the exponent. So that's going to be cube root of 64 is not 3, it is 4. Cube root of 64 is 4. And then 4 raised to the second power is 16. And then 5 to the negative 2. So that means you're going to take the inverse. So you're going to do 1 over 5. Once you do 1 over 5, the negative 2 then becomes positive, and then that's going to be 1 over 25. So 25 to the 1/2. Anytime you see 1/2, that means square root. 8 to the 1/3. Anytime you see 1/3 as a power, that means cube root. Again, 1/2 as a power means square root. A lot of times our brain just doesn't convert like that. We're like, "Ooh, what the brakes? Come on, what the heck? The exponent's a fraction. What does that mean?" 8 to the 2/3, cube root of 8 squared. 64 to the 2/3, cube root of 64 squared. 5 to the negative 2. When that exponent is a negative, that means take the inverse. Then the exponent becomes positive, and then you work it from there. All right, let's look at some terms and definitions. So we are studying logarithms. It is abbreviated log. If you take a scientific calculator, you're not going to see a key that says logarithm. It's going to say log because that's just how we abbreviate it. And the definition of a logarithm is the power. So this is the key word here. A log is a power to which a number must be raised in order to get some other number. So this is wanting to know what this log is equal to. So remember, a log is always equal to a power. This little number is called a subscript. It is always your base. I've got a little in this yellow box. This is your base. This is your answer. This is your exponent or your power. So this is your base. This is your answer. So they're wanting the power or the exponent that you're going to raise 2 to get 8. So 2 to what power is 8? So that's going to be 3. And for some reason, I think of this in my head, 2 to what power is equal to 8? That's what that problem is asking you. So you could think of that as a little thought bubble there. We do have a common log, and a common log is any log that's in base 10. And so they usually don't write base 10. Base 10 is a very common base. We use it, the thing that I think about the most that we use base 10 is the metric system. But they're not going to write base 10 because base 10 is such a common log. They're not going to write it. It's going to be understood. So if you see log of 100 and you're wondering where in the world is that little base, then as long as that word is log, then you know the understood base is always a 10. So this is problem is saying 10 to what power is equal to 100. 10 to what power is equal to 100. That's what you're thinking. And that's going to be 2. 10 to the second power is 100. We also have something called natural logs. This is when the base is e, and e is not an unknown value. It does have a value of approximately 2.71828. Natural logs are used in science. One of the things I can think of right away is carbon-14 dating. If we dig up some bones, we're trying to figure out how old the bones are. They test the carbon-14 and they use equations that have E in them. We also use E in business, like in a compound interest. If interest is compounded continuously, we use this value. So I like to say it occurs in nature. It is a natural number, kind of like a pi is a natural number. So if you see, and by the way, natural log is abbreviated. I should have done it right here. It is abbreviated LN. You would think it would be NL, natural log, abbreviation for natural log, but the L actually comes first. So on a scientific calculator, you're going to see it abbreviated LN. So if you see LN, they're probably not going to put a base here, and you're going to know that the base is an understood E. So you're going to think of that base being E. So this problem says E to what power is equal to E to the fifth? Because remember, this is the answer. This is the base. You're looking for the power. So the answer to this would be 5. All right. If we're converting, if we're going back and forth from log form to exponential form, there's a little graphic right here. I think this is a pretty good graphic. Down here is exponential form. A to the y is equal to x. This is called exponential form. And then this is log form. This gives you a little graphic, a little tip. This is log form. So your base is always this little subscript. What your log is equal to, this is always your power. What your log is equal to is always your power, your exponent, and then what comes after your base is always the answer. So in example 1, they're saying convert from exponential form to log form. So we're in exponential form, we're going into log form. So we do that by writing the word log. Then the subscript is our base, so 3 is our base. Our answer comes next, it's 243. And then our log is always equal to our power, which is 5. We're not solving anything. We're not evaluating anything. We're not simplifying anything. Sometimes we want to overwork these problems and they're just asking us to convert from one form to the other. In example 2, they're asking us to convert this log form into exponential form. So in exponential form, we start with the base. So this, since this says log and there's not an understood subscript, there's not a subscript, written, then I know that since that's log and not ln, that the base is an understood 10. So I know my base is 10. My power is always over here on the other side of the equal sign because logs are equal to power. So it's 10 to the negative 4. And then my answer is always just to the right of the base. So that's 0.0001. That would be exponential form. Again, you're not working anything out. You're just converting from one form to the other, kind of like English to Spanish, Spanish to English. All right, here's some for you to try. So since this is a video, you can stop it for just a second, work part A out, start it back, and then I'll have the answer written. And then you can work part B out, you can stop, and then work it, come back, and check the answer. So stop the video now for part A. All right, part A says, what is the equation in log form? So it's in exponential form. We're writing it in log form, so it's going to be log. The base is 4. The answer is 64, and this equals the power on the 4, which is 3. All right, hopefully you got the answer to part A. If you will try part B now, turn off your video. When you're done, turn it back on so you can check your answer. Part B says, what is the equation in exponential form? So they're giving us this ln 5. ln of 5 equals x. ln is a natural log, and it has an understood base of e. So when we go to write this in exponential form, e is going to be my base. My log is always equal to my power, so x is my power. And then 5 is the answer. It always follows my base. So e to the x is equal to 5. All right, hopefully you got those two correct. Let's do some evaluating. Evaluating to me is just working the problem out as far as it will go. Work out as far as it will go. We're not solving because we don't have an equal sign. So here we're just working it out as far as we can go. So we know that our base is 3, and we know our answer is 1 over 27. So what we know, let's talk about what we know. We know our base is 3, and we know our answer is 1 over 27. So that means we're looking for our power. We're looking for the power. So logs are equal to power. So since I have this 1 over, and that means I know that my power is negative because I'm doing the inverse. And then I'm thinking about 3 to what power is 27. So 3 to the third power is 27. So the answer to this problem is going to be -3. So 3 to the -3 power is 1 over 27. In example 2, we have a natural log. That means the base is e. Understood e, that's not going to be written. So this problem is saying e to what power, that's what we don't know, is equal to, again, this is our answer, e to the 7/2. So e to what power is equal to e to the 7/2, and the answer to this one would be 7/2. If our bases are the same, then our exponents are the same. All right, here's another chance for you to try. Some people can go just straight to the answer. If you want to write it in exponential form, you can. And then we're not going to do this 5th one. We won't make up our own problem. All right, so if you want to stop the video and see if you can work these 4 by matching them either to 1/2, -1/4, 2, or undefined. Here's just a little hint. Remember, you know the base, you know the answer. 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 So on all 4 of these, you're looking for the power or the exponent that you're going to raise your base to. So if you'll stop your video and work these 4 and then turn it back on, and then I will go over the 4. Number 1 is asking you 7 to what power is 49? So that's going to be 2. 7 to the 2nd power is 49. Number 2 is asking you 6 to what power is -36. Since our base is +6, there's not any power you can raise +6 to. 6 to the first power is 6. 6 to the second power is 36. 6 to the -2 power is 1 over 36. So there's not an answer for this one. So that's why we would choose undefined. Number 3 is saying 49 to what power is 7. And the only power that we can raise 49 to get to 7 is the power that takes the square root of 49. And the power that takes the square root is always 1/2. And then the last one, I'm sure by process of elimination, you can figure out it's -1/4, but I'll talk about it anyway. 16 to what power is equal to 1/2? So because it's 1 over, then that's going to clue me into the power is negative. And then it's going to be 1/4 because that's the same as the 4th root. And the 4th root of 16 is 2. So it's going to be 16 to the -1/4 because that's going to be 1 over 2. So this one's going to match with -1/4. All right, hopefully this lesson on 6.04 was helpful to you. I'm not here to let you do your chats, but hopefully you learned a little bit. If you're saving your whiteboards, don't forget to do that. And if you have any questions, I am going to try to answer emails at least in the mornings and at lunch.